Hello, hi. This is a demo for my research project that is delay and cost awareness computation offloading using deep learning enforcement learning in fog cloud environment. So initially, we'll start with the uh, opening Anaconda Navigator. Once we open the Anaconda Navigator, we'll proceed with the other parts. As we know that Anaconda Navigator is a desktop GUI. It it makes it easy to launch application and manages packages and environment without using command line commands. Also, we would be using Spider for execution of our Python codes and Python files. As Spider is a free developing environment that is IDE that is included in Anaconda. It includes. It also gives a lot of functionality like editing, interactive testing, debugging, used for scientific programming in Python language. So as I am using deep reinforcement learning, so I would be using, as I have used libraries such as TensorFlow to run my program in neural networks. For that, initially when tried uh, installing TensorFlow, I opened the Anaconda command prompt over here and I installed uh, Anaconda, the TensorFlow command over here. And once I run, I also created my environment. And when that is done, by using the command prompt, that is the Anaconda prompt, and so I have already created my environment over here. So once I switch to my environment, it is automatically you know uh, diverting uh, to the to that particular folder or that location. So I have already have all this platforms ready over here. So I would be just using Spider for my, I'm just launching it. I would be just using this particular platform for this particular environment for executing my program. So as you see that we have multiple program. This is the main page where different coding has been done over here. So I would be focusing on a lot of things over here. That is the data set which I have used for identifying the data for offloading, and what are the things that is important as per the proposal approach. So if I would have navigated, or if you have given your information, so if I go through my project file over here, I see you will see that I have used data sets. So this is one of the data set which I would be using, which exactly this is not exactly the data. This is just the result. The how much delay energy consumption or done, and the data set over here. This is a data set. It is in .csv file, which is a for cloud uh, data, wherein it is mentioned memory data in KB, cloud loads, latitude, longitude, all these things is being calculated over here. So once we feed the data inside the uh, code, it executes and it gives us an output. So this is one of the data. Also, the other important data that we would be using as we come across, if we have gone through the project module, um, we have sensors, that is the IoT devices, that is sensor 1, sensor 2, and sensor 3, which is giving, we would be feeding this into our programming, and we would be isolating, and and with that we would be um, given a better cost awareness or better cost reduced model. So these are the data sets which are available. Going back to the programming. So this is, as we see that we have used multiple libraries, we have called functions. So these are the things which we have used over here. So uh, talking about the libraries over here, like that we have used in the machine learning, is that the experiment of the deep learning reinforcement learning based data fusion are being used by using Python programming language. Moreover, we run the deep reinforcement learning algorithm by using or Python libraries such as the num file, then the pandas and the plotting libraries with the Python version of 3.6.8. So uh, so we would be compatibilating with different numerical calculation libraries by using TensorFlow, as I mentioned earlier, as we are using deep reinforcement learning. So, and also mentioned few data sets which we would be feeding into our program. And so going back to, like, we, as you might have seen that the first initial steps, we are just importing or calling the function from other Python documents. So the first important thing that I just want to let you know is the equation.py, wherein this is the most important, what you say, the core of the project. Like, we would be, as the project states, that we would be calculating delay and cost awareness computation offloading using the deep reinforcement learning. So from line number 26 27 onwards, we'll see that we have given a function, we have written a function over here, like total delay, total cost, and the computational cost, how exactly it has been executed. So we are calling this function, this particular code from to the main, and it executes the data, and it gives you most uh, efficient cost, as well as the delay, the time it takes. Also, this is the memory file, wherein all the uh, layers of the clouds are being mentioned, and the functionalities are being called to the main page, like how the network from the memory is being identified and being utilized to the main. Also, when we go to optimization over here, optimization is all the mathematical calculation being carried out in this particular location. As we run this page over here, as we see that uh, it will show the total average, the number, the total cost, everything would be shown over here, like considering the data set. So the optimization is being seen over here as we run. So the program is running, as you see that it's started initializing as point 1, point 2. So you will observe that. And so it is actually proceeding to run. So this might take a while. Point 0, point 1, point 2, point 3, and it will gradually give you an output on how much average cost. So over here we'll be given a the average total cost, and the average time per channel is being given over here as a result. See, all this function is being called in the main page over here. So I have created two main pages over here for different records, as the data set itself is a huge data set. So to execute uh, we have given a specific amount of data, like from 10,000 records, we would be, uh, calculating, or we would be identifying the best possible, the cost aware computation offloading, how much delay it has been cost, what are the normalization rate, and so on. So this is from now, like now I'm just executing for just 10,000 record over here. So once it is completed, this might take 15 to 20 minutes, depending, as it is 10,000 records, so it will generate uh, better, and it will take some time. It's like best out of the uh, from a lot. So also, giving an information over here, it's like the experiment model applies, as we stated, that it applies the deep reinforcement learning model on the offloading trace data. So the offloading action are either in the form of binary numbers as 0 or 1, um, and it also decides and consider it also takes a decision considering the channel gain, delay, and cost to execute the IoT application in the fog cloud environment. And the model run the algorithm using Python programming, and output of the results in the IoT application request. So as we have run the optimization, so it is actually on the process to execute. So you will get a result right now after 0.9. So it will show you an the average, the time cost, and the average time per channel would be shown over here. So yeah, there you go. So the time cost for this is 229.65. Average time per channel is 0.22, and the gain and the maximum ratio is given like this. So this is when we execute the optimization. Okay, so now we are going to run the main program. So we'll just close these one, because I'll just run this code. Just a second, just give me a moment. So yeah, we'll just run this code over here. Okay, we'll just run. So once this code is run, this will take a couple of minutes, like as stated, like as we are using deep reinforcement learning, the library TensorFlow is optimizing using API deep neural network libraries, because it is fetching data, and to enable them in the operation, it rebuilds the TensorFlow. So, and it compiles the flag. So as how the output given over here, like this thing, it will also be shown over here, and the output would be given in a while. And also over here on the top, you will be able to see the graphical representation. What are the things that has been carried out would be shown on the top. So we'll just wait for a while once this get executed, as it takes some 15 to 20 minutes to get executed, and we'll be able to you know uh, identify the total delay, total cost, the energy consumption, and the normalization rate would be evaluated from this experiment. So we'll just wait for a while. So as this is actually getting executed, I just let you want to know that I have also constructed the main page. As you see that we have sliced the data in 10,000, so that it will fetch the best out of it. So over here you will see, as I have mentioned earlier, um, the data or the deep learning for offloading decision would be taken either in 1 and 0. So this is the records, and out of this it will, take it the best possible way, uh, depending upon like the best cost and the delay and the utilization, normalization, everything would be calculated. So this is for the 10,000 records. So I've also created a document, like similar to this document. Like this is for when you open the main page over here. The coding is everything same, just 30,000 record. This script is for 30,000 records. As if I run this code, it will take 25 to 30 minutes to execute. So this is actually, it will take out of 30,000 record, it will fetch the best possible way, best possible output. Also, if I go to the second code over here, um, like if I open the main, it will show 20,000 records. See, we are inputting 20,000 record, so the 20 out of 20,000 record, it will fetch the best possible way. So for now, I'm just running 10,000 record, as it takes lesser time uh, to compute or to give an output, apart from the 20,000 record as well as the 30,000 record. So we'll just wait for a while, and you will able to see the output. As you see that it is gradually increasing, the it is executing, it's 0.1, 0.2, so we need more 0.3, 0.4, 0.5 till 0.9, and once it is completely executed, we'll be able to see the final output. So we'll just wait for a while. So it has gradually increased, like the execution, as it has gone to 0.4, 0.5, 0.6. Now we need to wait for 0.789. Once that is done, once this operation is done, we'll able to see the best possible output for the total cost, delay, the energy, and the average normalization computing rate, average execution time would be seen. So we would be receiving the output, as it has already been 0.8, 0.9. So we would be receiving an output in a while.